So now we're going to take a look at DC circuits. In order for you to solve problems in DC currents and circuits, you're going to need to identify series circuits and parallel circuits. So I want to show you some strategies on how you can identify what type of circuit that you have, because those are going to be essential for you solving problems. So we have two different types. We have series circuits and parallel circuits. If you have a series circuit, what are the characteristics of a series circuit? Well, let me draw one on the board fast. So this symbol means a power supply. That could be a battery or a power supply. And this squiggly line represents a resistor. So the power supply has a voltage. This is R1, R2, and R3. Now, there is one simple condition that you have to satisfy to identify whether the object or the circuit is a series circuit. Does the current have options? If the current has absolutely no option but to go through one element and then go through the next element, then those two elements are in series. When I say the term element, that means something in the circuit. That element could be anything. It could be a resistor, a diode, a power supply. So everything in a circuit could be considered an element, but not every element is, say, a resistor, or every element is a capacitor. So I just might use the term element generically, meaning something inside the circuit. But nevertheless, so let's take a look. If the current comes out of the power supply, and I is our symbol for current, if it goes through resistor 1, you see that it has absolutely no option but to go through resistance 2, and then continuing on, it has no option but to go through resistor 3. So therefore, resistors 1, 2, and 3 are considered in series. So again, how do you identify a series element or elements that are in series? Assume a direction of a current going through one of the elements. If the current has no choice but to go through the next element, then those two elements are in series. Now, let's take a look at parallel. Parallel is a little bit more involved in terms of what you have to identify to meet the conditions. So let me draw a parallel circuit. R1, R2, and R3. So here we have our power supply. And then we have 3 resistors that are connected in parallel. Now, how are you able to identify a parallel circuit? Simple. The first question you ask is, does the current have options? So what I mean by that is, if the current comes to this junction, you see that it doesn't have to go through resistor 2. It could branch up and go through resistor 1. I didn't put a 1 there. It could go through resistor 2, or the current could go down and go through resistor 3. So that lets you know right off that you've met the first condition. The current has options for what direction it wants to go. The second condition that must be met is that each side of each of the resistors must share the same junction in common. So as you can see, resistor 1 meets at this junction, and it's in common with resistor 2, and it's in common with resistor 3. So they all reference the same point. They do that on the left side of the resistor, but they also reference the same point on the right side. So since the resistors both on each side of the resistor reference the same junction, respective to each side of the resistor, therefore we can say that those 3 resistors are in common. They meet 2 conditions. 1, the current has an option in which direction it wants to flow. It could go through the first, the second, or the third. 2, each side of that resistor is in common with each other. So those are the conditions that you must meet for a parallel circuit. Now, just because the current has options doesn't imply that it's in parallel. Let me give you a quick example. If I drew this circuit, notice if this is R1 and this is R2 and that's R3, R1 and R2 are neither in series with each other, nor are they in parallel. And let me show you. The current, if the current flows through the circuit, the current could go through resistor 1. It could continue on to go through resistor 3. So the first condition is met. The current has options in which direction it can flow. However, though resistor 1 and resistor 2 share this junction, this side of resistor 1 does not share this junction with resistor 2. Why? Because it is in common with the positive side of the power supply. So because this element is in the way of this side of the resistor and that junction of 2, 1 and 2 do not have both sides in common in terms of the junction that they reference. So resistor 1 and resistor 2 are neither in series, nor are they in parallel. But you can look at the circuit and see that resistor 2 and 3 are in parallel with each other. Why? Because resistor 3 and 2 both reference, on each side of their resistors, they both reference the same junction respectively. And the currents have options which way they go. If it goes through 2, it doesn't have to go through 3, it can go back here onto the power supply. So that's the first strategy that we have to get down pat. Do you know how to identify a circuit that is in series, parallel, or neither? Go over the video again to see if you can familiarize yourself with it. Then go to your physics book or look up some different circuits on the internet and see if you can identify the circuits that are in series and are in parallel.